examples of matrix addition. So what I'm covering today is just the last part of chapter 2 that we're going to be discussing, okay? It's essentially 2.4 through 2.6. All right, so we were talking about matrix addition and subtraction and the like. So what I would like to do is just 2 more examples of matrices, but we get to actually use some algebra here, okay? Oh, I know, right? So, the first example that I would like to do is the following. I want to take this matrix, and I want to add it to this matrix. Notice you can tell my 2's from my z's because I cross my z's. And what we want to do is we want to solve so we can get the values of x, y, z, and u. All right. Now, will you guys grant me the following? The left side looks more complicated than the right side. Totally. Can we simplify our left side? I mean, what our goal is we want one matrix equal to the other matrix. Can we add these 2 matrices? Oh, yeah. Let's do it. How do we know we can add it? Because they're the same size. So, what is x plus negative 2? X minus 2, or x plus 2. Then, my next term, don't I have negative 2 plus z? What is 3 plus a negative 1? 2. And we get y plus 2. Does everyone see how I got that matrix on my left-hand side? Now I have one matrix equal to another matrix. You may or may not remember a particular comment that I made, but I will remind you. My comment was the following. 2 matrices are equal if they're the same size and your corresponding entries are equal. You guys with me there? So, if I'm telling you, yo, these 2 matrices are equal, doesn't that mean that x minus 2 has to be equal to 4? Yeah. Can we solve that? Yes, one hopes. X equals 6. Okay? Doesn't negative 2 plus z have to be equal to negative 2? So what is z equal to? 0. Celebrate. Okay? Now, 2 must be equal to 2u. So what is u? 1. Right? Divide both sides by 2. And last but not least, doesn't y plus 2 have to be equal to 4? So what is y? 2. Yes? X minus 2 equals 4 and do all that? Yes, you can. But my next one's going to be a lot more complicated and it's not going to just be that simple. But yes, you could in this example. It's a lovely question. All right. Want to see one more example of this? He's going to be more involved. Okay. What if I have this guy? 1, 2, 3, 4, x negative 1 minus 3 times y minus 1, 2. have this one, you can't quite do the same thing. Now, the reason why I encourage you guys to show every step is just because if you make a numerical mistake, we can give you partial credit. Okay? So we got a lot going on here, don't we? We certainly do. Okay? Our goal is the same though. We want to get one matrix on our left, one matrix on our right, and then solve for the variables. Okay? So let's deal with our right side first just because it's easier. What do I do with this 2? Good, I multiply each entry in my matrix by 2. So I get -8, -2u, 0, -2, 8, 8. Questions there? Cool. All right. Now, you can look at your left side one of 2 ways. Okay? I claim that one of the ways that the way I'm going to solve it is actually one that's less prone to error. Do you agree that you could cover up your negative and multiply your whole second matrix by a +3? And then you could subtract your matrices? Okay? But do you guys remember from an algebra class, if you subtract something with more than one term, you have to remember to distribute the negative sign throughout your parentheses. You guys remember that from algebra? So what I would encourage you guys to do is actually change this to plus -3 times that. It'll make everything easier in the end for you guys. Okay? So I'm going to rewrite my first matrix, 1, 2, 3, 4, x -1. I'm going to make this a plus. And now let's multiply our second matrix by our -3. What does my first term become? -3y plus 3. -3 times 2 is -6. -3 times 1 is -3. Again, we get -6 here. We get a -12 there. And here, don't we get a -6z minus 3? All right. What's my next step? Add these 2 matrices. Do you guys like this? No? Oh, I think it's so cute. If I told you that my cats are cute, you'd probably be like, well, if you think that's cute, I hate to see your cat. All right. 1 plus -3y plus 3. Combine like terms. Don't you get -3y plus 4? 2 plus -6 is -4. 3 plus -3 is, yeah. 4 and -6 is -2. X plus a -12 is x minus 12. And do you agree -1 plus -6z minus 3 is -6z minus 4? So the reason why I would recommend you always show all work is precisely because if you make a little mistake here, that's going to affect your answers. But if you've shown your work, we can at least follow that. Questions? All right, let's solve for our variables. So if these 2 matrices are equal, isn't -3y plus 4 equal to -8? Can we solve this? Absolutely. Scoot your 4 over, so you get -3y is -12. So what's y? 4. All right, next one. -4 is -2u. What's u? 2. Get it? pretty profound, huh? Even deeper. Negative 2 is equal to negative 2. Next, don't I have x minus 12 is equal to 8? So what's x? 20. And last but not least, negative 6z minus 4 is equal to 8. What do? First you add 4 to both sides. So don't you have negative 6z is 12? Divide both sides by negative 6, and you're going to get z to be negative 2. If you don't remember algebra, please try to remind yourself. All right. Don't worry, I won't have these ones like this. Okay, next. I'm not going to say a whole heck of a lot in section 2.5, but we need 2.5 in order to do 2.6. See, you know, at the end of class today, we're going to be able to solve bigger systems of equations than just 2 equations and 2 unknowns. So that's what we're building off for. All right? First off, in order to add or subtract 2 matrices, remember they just needed to be the same size. Okay? It turns out that such is not the case when you multiply matrices. Right? When you multiply 2 matrices, say matrix A times matrix B, here is what must happen. I'm going to write it out, and it's going to look a little complicated, but then I'll write it out neater. The number of columns in A must be equal to the number of rows in B. In other words, and you don't even have to write this down, you guys, I want you to watch this at the very least. Okay? If A is an m by n matrix, in order to multiply it by B, B must be n by who really cares what. In other words, these 2 numbers must be the same in order for matrix multiplication to work. Okay? I will not ask you to multiply 2 matrices that cannot be multiplied. Okay? And not only that, but it turns out that your product matrix, in other words, the matrix A times B, is equal, in terms of its size, it's an m by k. The outer numbers give you the size of your product matrix. Let me show you actual numbers. I think you guys will like it better. Suppose A is a 4 by 3 matrix. And B is a 3 by 7 matrix. I claim I can multiply these 2 matrices. You know why? Because my inner numbers are the same. Okay, the number of columns in A is the number of rows in B. And if you want to know the size of matrix A times B, it's going to be a 4 by 7. Do you want to see something cool-ish? Yeah. Can I do matrix B times matrix A? Well, what size is B? He's a 3 by 7. What size is matrix A? He's a 4 by 3. Can I do this multiplication? No! Wow. I know this doesn't seem very deep to you guys, but something that we all take for granted is that we have our commutative property of multiplication. In other words, 5 times 2 equals 2 times 5. Matrix multiplication is not commutative. Precisely because one way you may be able to do the product, but the other way you might not. Isn't that wow? Yeah. show you one example of how it's done. You guys are going to have your calculator do it. Okay? So, I know, right? But let me just show you one by hand so you can kind of get the vibe of it. Okay? You don't have to write this down, so just watch me. We don't need our calculators yet. So let's have a matrix be like 1, 2, 3, 4. Wow. Okay? That's a 2 by 2 matrix. So all I know is this has to be a 2 by something. Do we have it be a 2 by 3? Okay. So 2 rows. So how about we have -1, -2, -5, 4, 0, and 1. Okay? So I can multiply these because these inner numbers are the same. Do you agree that the size of my product matrix is going to be a 2 by 3? Because remember I told you it's the outer numbers? Again, you don't have to write this down. I'm not going to ask you to do it, but I want you guys to at least appreciate your calculator as much as possible. Okay? So, do you guys agree, in order to find this term, he's in my first row, first column? So what I'm going to do is take my first row and my first column, and the way they intertwine with each other is you take this times this, plus this times this. That's how you do matrix multiplication. So I have -1 plus 8, so I get a 7 here. This is my first, this guy is my first row, second column. So now I'll jive my first row with my second column. Do you agree I have -2 plus 0, so that's a -2? This is first row, third column. So now I'm going to let my first row hang out with my third column. You multiply and add them together. 1 times -5 is -5. 2 times 1 is 2. What is -5 plus 2? -3. This is my second row, first column. So now I'm going to let my second row hang out with my first column. I do 3 times -1 plus 4 times 4. Do you agree I get 13? Now, second row, second column. So I get -6 plus 0 is -6. Aren't you glad you don't have to do this? Actually, I think they're kind of fun, but I would. Last but not least, we have -15 plus 4, -11. All right. So, that's what I want to say about matrix multiplication, except for one other thing. Let me do one more. Let's just take 1, 2, 3, 4, and I'm going to multiply it by my really special friend 1001. Do you want to know why he's my special friend? You'll see. Let's multiply these guys. Don't you take this times this plus this times this? 1 plus 0 is 1. Now for here, you do this times this plus this times this. So 0 plus 2 is 2. And for this term, you do 3 times 1 plus 4 times 0. What do you get? 3. Last but not least, 3 times 0 plus 4 times 1. What do you get? 4. Oh my God! We took this matrix times this really cool guy, and didn't we get our matrix back? What does he remind you of when you're thinking of just regular numbers in your multiplying? Doesn't he remind you of the number 1? Yeah, because any number times 1 is itself. Okay? So I want to tell you that he actually has a name. When we're talking about square matrices, we have what's called the identity matrix. It's when you have ones along your diagonal So you could have 1, 0, 0, 1. A 3 by 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1, etc. And the beautiful thing about your identity matrix is any matrix, we'll call him I, times your identity gives you your matrix back. Neato, huh? You guys with me this far? We're going to be using this idea very shortly. Okay? There's one more thing I need to establish, and then we're going to learn how to solve bigger systems. Okay? All right. So let's go back to just regular old numbers. Well, we know 5 times 1 is 5. He's like our identity matrix, isn't he? Yeah. All right. Remember, we also have things called multiplicative inverses. In other words, I'll show you. 5 times 1/5 gives you your identity. Right? Your multiplicative inverse. We've talked about additive inverses already. Your multiplicative inverse is essentially, isn't it just your reciprocal? You're asking, hey, what number can you multiply your number by in order to get your identity? So, like, what's the multiplicative inverse of 2/3? 3/2. If you don't remember, it's just your reciprocal. You guys with me here? Okay? Any questions so far? Now, it turns out that not every matrix has a multiplicative inverse. But all of the guys that you're going to be interested in do. Okay? You will not have to find your multiplicative inverse. We will have our calculators find your inverse matrix. There are computations that you can do in order to find them. But essentially what I want to say is if you have a matrix A, if he has an inverse matrix, this is how we show the inverse matrix. The beautiful thing about that is when you multiply them, you get your identity matrix. And your identity matrix essentially serves as the number 1. Now, if you are like, where are you going with this stuff, Lauren? Here we are. Okay? This is all in preparation for the moment we have all been. Okay? Are you ready? Now what I'm going to do is I'm going to write a problem down to motivate. And then I'm going to play with a little bit of theory behind what we're doing. Okay? So, suppose we want to solve this. Suppose I want to solve my system. 2x plus y plus z equals 2. 3x plus 2y plus z is negative 3. And 2x plus y plus 2z is 1. Now, we had already talked about writing this in matrix form. Do you guys remember that? Okay? And I told you guys when I explained the first round that we're actually going to write it a little bit differently. And here's where we're going to. It's really not very difficult. On anything, the way I will word this is write in matrix form. And I'll write it as AX equals B. Okay? Let me show you how we're going to want to write this. And then I'm going to show you that this is a very good way to do it. Okay? My matrix A is literally the coefficients on my left side. Do you agree? I have 2, 1, 1. And then my next row, I have 3, 2, 1. bottom row, I have 2, 1, 2. Everyone with me there? Now remember, what we would then do is we would put a line and essentially as our equals, and then we would have the other side. Okay? We're going to write it a little differently. This is matrix A. That's our coefficient matrix. X is also a matrix. He's X, Y, Z. Equals, and your matrix B is whatever it is equal to. This will always be your first step. Are there any questions, first off, how I took my system and wrote it in matrix form? All right, now what I would like to do is just have you guys just watch me here, and I'm going to justify that what I have here is exactly the same as what I have here. Okay? First off, this is a 3 by 3 matrix, yes? Isn't he a 3 by 1? So I'm allowed to multiply them. Do you agree? Yeah, my inner numbers are the same. You're not going to have to do this, but I want to show you that what I'm doing is totally kosher. Okay? So, if I wanted to multiply these, wouldn't I just take this times this plus this times this plus this times this? Yeah. Wouldn't I get 2x plus y plus z equals 2? Whoa! All right. Next one. This times this, so 3x plus 2y plus z equals -3. Last but not least, 2x plus y plus 2z equals 1. So do you see how these are the same? All right. So, you don't need to write for a little bit. I want to show you something. Do you agree we are now in the form ax equals b? Right? A times x equals b. Do you all also agree that I want to know what this matrix X is? Right? Because that'll give me my X value, my Y value, and my Z value, which is ultimately what my goal is. Everyone with me this far? All right. Well, the thing is, if I want to get X alone here, you can't divide by matrix A. Isn't that what your temptation would be? Because how do you want to do multiplication but division? You don't divide matrices. Okay? So, here is what we do. We find our inverse matrix of A, and we multiply on our left side. But fair is fair. If you multiply on one side of your equation, you got to do it on the other side. You with me this far? I'm just motivating what we're going to be doing in our calculator. You okay this far? By definition, if these guys are matrices that are inverses of each other, what is A inverse times A equal to? 1, or our identity matrix. Yes? And what is your identity matrix times anyone? Just your anyone, right? He's like a 1. So 1 times x is essentially x. So that's what you want to write there. In order to get our matrix X, what we need to do is find the inverse of this matrix and multiply it by this matrix. Okay? You all with me? Kind of, sort of, at least? Okay. So, take out your calculators. Okay, so I'm looking at my calculator and I see my number 7, and then I look to the left and it says log, and then I look up and it says x squared, and then I look up one more time and I have a button that has x to the negative first and then it says matrix above it. I want to get to my matrix. How do you get to it? You hit second this button. Now these are so fun. I'm just saying. Okay? This is what I have. You guys might not have anything whatsoever in here. Don't worry about it. Unlike those lists that you enter, you don't have to clear your matrices out. They just supersede each other. Okay? Everyone with me this far? Cool. Now, what we need to do is enter our matrix A and enter our matrix B. When you enter things, you're editing them. So go on over to edit. So you go on over to edit. Now, do you see how the cursor right now is right here at matrix A? Yeah, so hit enter. Now, right now I got a 4x4 matrix in there. You might have zeros there. It doesn't matter. What size is matrix A? He's a 3x3. So literally hit 3, enter. See how it shrunk? 3, enter. Okay? And now what you're going to do is enter your matrix A. So you're going to hit 2, enter. You go across each row. 1, enter, 1, enter. Then 3, 2, 1, and 2, 1, 2. So step 1, enter matrix A. And next, we'll enter matrix. You guys all with me on matrix A? Got it? All right. So we can get out of there if we want. And now let's get back in. And again, we want to edit. But you guys, you have to go down to matrix B. So hit your arrow down and then hit enter. What size is matrix B? He's a 3x1, right? So hit 3, enter, 1, enter. And hit 2, -3, and 1. Hit quit. So right next to your second button is mode. Hit second mode. Are you okay? Cool. All right, now get out of that screen. Everyone with me this far? Okay, now, do you guys agree in order to solve this, we want to do A inverse times B? Let me show you how to do that. Okay? So what you're going to do is hit second X inverse to get to our matrix. And we're at A. We want A, don't we? Kind of, sort of. So right now you should have an A on your screen. Nope. Names is fine. Names, just hit enter right when you're there. Okay? Now, don't we want this guy to have an inverse on him? Guess what? To get that, just press that X inverse button. The same button that you're hitting second is the same button you hit. So just hit your X inverse button. Ooh, I hit squared. Don't do what I'm doing. Right? It's like the whole thing of parenting. Do as I say, not as I do. You guys got this there? Questions? You okay? Cool. Now, don't we want to multiply them? So hit times. And we want to multiply them by matrix B. So again, hit second matrix. But now we want to go down to B. So go down 1 and then hit enter. You guys with me? Now hit enter. We did it. What we got is X is 8, Y is -13, and C is negative 1. What did you enter for? What did I enter for what? Your B matrix is what it's equal to. This guy over here. We'll go through another example. In other words, you guys, if I plug in 8, x equals 8, y is negative 13, and z is negative 1 into each of these equations, I'm going to have equality all over. You guys want to see more examples? Yes? I can't hear you. What? I'll show you at the end of class. Okay, essentially what you're going to do, let me show you this again. Hit clear. Do you have a blank screen? Okay, so I'm going to hit second matrix. Are you here? Now just hit enter. Okay, then hit your X inverse button, the same button that you were hitting second, then times, and then second matrix, but now we want B, so we'll go down to B, hit enter, and then enter. Okay? You guys want to solve another system? Let's do it. Isn't this cool? I know it's really time consuming just to explain how to push buttons on your calculator. Should we solve a bigger system?
No.
Let's do it. Suppose I have x plus y plus z plus w equals 2. X minus y minus z plus w equals 8. Y plus 2z plus 2w equals 4. And x plus 2y plus z minus 2w equals negative 1. All right. Part A, whenever I ask you guys to do these, is write in matrix form AX equals B. Can we do that? Absolutely. Okay? My matrix A, tell me what my first row is going to be. 1, 1, 1, 1. It's pretty sweet, huh? What's my second row? 1, negative 1, negative 1, 1. What's my third row? 0, 1, 2, 2. Right? There's no x. And 1, 2, 1, negative 2. You with me there? Okay, my matrix X is X, Y, Z, W. And what is my matrix B? 2, 8, 4, negative 1. Any questions on that? All right. Now, you might wonder how would your other part be worded? What I would say is solve using your inverse coefficient matrix. That's longhand for, hey, do A inverse times B. All right, so don't we need to enter these two matrices into our calculator? Okay, I always have this part here worth more than this part here, only because it's easy to make typos, and I don't want you to lose a bunch of points in case you enter the wrong number. So you're going to hit second matrix. How do we edit it? Well, we go to edit. What size is matrix A, you guys? He's a 4 by 4. 4, enter 4. All right. let's enter the matrix A. So we have ones, and then we have 1. I won't talk through it because I don't want to mess you guys up. And then enter your matrix B. What size is matrix B?
4.
He is a 4 by 1. So 2, 8, 4, negative 1. All right. So now I'm going to do my computation. I hit second matrix. I want A. So I hit A. What do I hit now? That inverse button, yes? Times matrix, go down to B. And there we go. How would you write that? That's a great question. So what I would have is x equals y equals z equals w equals. So you would say 12, negative 24, 21, and 27. Now, I want to make one quick comment, you guys. Is everyone listening? Okay? You will have a problem like this on the test. Okay? I honestly, on an exam, I will give you a word problem. Of course I will, right? And I'll ask you to, part A, define your variables, and part B, set up your system. Wouldn't that get you this far? Okay? On a test, I wouldn't ask you to solve what you set up. Okay? The reason why is if you set it up incorrectly, you might try to solve something that's totally unsolvable. So, what I do is I break this chapter up into 2 separate types of problems. One, you will have, just like I said, a word problem, where I'll ask you to define your variables and set up, but don't solve. A separate problem, I'll give you an actual system that I already know can be solved, and you'll solve it using A inverse testing. Again, the reason why I break it up into 2 separate problems is I believe I'm testing 2 separate things. One of them is given a word problem, can you write a system? And then the other one is given a system, can you solve it? But again, if you set up your system incorrectly, you know, again, you might be solving a system that's not solvable, and that would be a waste of time.